So today I am going to present my project on credit risk modeling loan classification. So the main objective of this project is to predict whether a loan applicant will repay the loan or not. So this is very important for banks because it helps them reduce financial risk and make better decisions while approving the loans. So in this project I used a data set named loan detection. So it contains various features like applicant income, loan amount and other financial details. So the target variable is the dataset is loan status label, which represents whether the loan is approved or not. So first I imported all the required libraries. Then for example, pandas is used for data handling, numpy is used for numerical operations, and sklearn is used for machine learning models. Then we also imported functions like trend test, split, logistic regressions and random forest clarifier. So I loaded the data set using pandas. So then in fourth, pd read CSV is used to read the file and store it in a data frame. Then I used df head to display the first few rows and understand the project of data. Then exploratory data analysis EDA. So next I perform exploratory data analysis. I checked for missing values using df.isnull.sum. Then I check data types of columns. I also analyze the target variable using value counts to see how many approved and reject loans are present. Then this helped me to understand that the data set is slightly imbalanced. Then data pre-processing. So after EDA I prepare for the data for modeling. Then first I separated input features and target variable. So x is a input features and y is the target. Then I use train test split to divide data into training and testing sets. So I used 80% of data for training and 20% for testing. Then after that I applied standard scalar syntax explanation. So fit transform used on training data, transform used on test data. Then this one. Then logistic regression. So I started with logistic regression as a baseline model. So in a code we create a model using logistic regression and train it using fit. So then predictions are made using predict. So to evaluate the model I used accuracy score, confusion matrix and classification report. So the model gave good accuracy but it was not performing well for the minority class. Then handling imbalanced data. So to improve the performance I handled the imbalanced data set using two methods. So first is class weight. So I used class weight is equals to balanced in logistic regression. Then this gives more importance to minority class. Then smart, which is oversampling. So I use smart to create the synthetic data. So syntax is smart dot fit underscore resample. So this increases the number of minority class samples. Then after applying smart the model performance improved, especially recall. Then random forest modeling. So here it is an ensemble model that creates multiple decision trees. in code. Random forest classifier, n estimators is equals to 200. So means 200 trees are created, and this model perform better than logistic regression. So I also check feature importance to see which features are most important. So the model evaluation, I evaluated the model using ROC AOC score, so which measures how well the model distinguishes between classes. And I also plotted ROC curve using matplot library. So a higher AUC score means better model performance. Then it has a conclusion, like logistic regression gave baseline results, mode and class balancing improved performance. So random forest gave the best accuracy. So the future scope is which is in future we can use advanced model like XGBoost, perform hyperparameter tuning Deloy and model using Streamlight. So thank you, and the project is by the Madhavi Patil.